Yeah, so just to reinstate, this is winter 2017. All right, question number 2. The result of 2 tests on solution X are shown. Reagent added aqueous sodium hydroxide, and what we see is that on a few, with few drops, it gives a white precipitate. So that tells me it could be aluminium, calcium, or zinc. It can't be a transition metal because this is white precipitate. And then on adding in excess, it dissolves. So that means it can't be calcium because aluminium and zinc are the ones that dissolve in excess sodium hydroxide. Now with ammonia, it does the same thing except it does not dissolve. So zinc is the one that dissolves in both of them. Calcium is the one that does not in both of them. In one, it doesn't even form a precipitate. And aluminum is the one that dissolves in sodium hydroxide and not in ammonia. So our answer is going to be aluminium 3 ion. Which diagram shows the arrangement of particles inside a balloon containing a mixture of gases, nitrogen and oxygen? So there are a couple of concepts that are being tested in this. Number one, the idea of diffusion or the idea of kinetic particle theory that particles are moving at random. So if somebody is not believing in that, then obviously they might choose B because B is the one where they are not randomly arranged. There is a definite order that the white ones are on one side and black ones are on the opposite side. So that can't be right. Second idea is that gases, nitrogen and oxygen are both diatomic, which means that the molecules are going to be two of the particles, two of the atoms connected together. And it's a mixture, so they're going to be two different kinds of particles. D is basically a compound because they have reacted together in that and formed a molecule where one nitrogen atom and one oxygen atom is there. A and C are mixtures where we have them randomly arranged, but C is the one where they're diatomic. So for both the reason that it is diatomic and it is randomly arranged, we get C as the answer. Okay, a student follows the rate of reaction between marble chips, calcium carbonate, and HCl. Now, the equation is given, and if we apply the state symbols here, we know that we are going to get gas here. Okay, this is liquid. This is calcium chloride is soluble, so it is aqueous. And so what we're going to see is there's a solid here, there's a solution here. So the solid is going to dissolve, and we're going to get bubbles of gas. So both of those can help us figure out a decent way of measuring rate of reaction. We can judge by the change in mass because carbon dioxide goes away. We can judge it by dissolution of calcium carbonate because it goes away, but obviously it's going to be a little hard to measure using that. Similarly, we can judge it by the idea that we are collecting carbon dioxide. But again, carbon dioxide is slightly soluble in water. So if you collect it over water, it can be a little more difficult to collect the accurate amount. Okay, so let's see, what are they saying? Is one a good method? So what we're doing here is we have carbon dioxide coming in, it's slightly soluble in water, so we can still collect it, and that will tell us the rate at which it's happening, sure. So 1 is a good way. 2 is also a good way because there's a loose plug, so carbon dioxide that's produced can simply leave out of this mixture. So we will see a change in mass, and that balance allows us to do that. So this would be a good idea. 3 isn't allowing us to measure anything except how much HCl is used. But उसका क्या फायदा हमें? हम HCl सारे का सारा एक्सेस में डाल दें. कोई रिएक्शन को तो मेजर नहीं किया हमने रिएक्टेंट्स को मेजर किया है, प्रोडक्ट को मेजर किया ही नहीं. And if we want to find rate of reaction, we have to measure the products in some way. So 3 is wrong. And 4, we are collecting carbon dioxide and measuring the amount. So 4 is also right. 1 is not the perfect method, but 1 is not entirely a bad method. It will work. 2 will work. 4 will work. 2 and 4 are good methods. So I would suggest that 1, 2, and 4 are the answers. We cannot do 3. I asked you to make notes on the side. So do make a note here that to measure rate of reaction, we need to measure the product, not the reactant. Okay, that helps. Like there is a way to measure reactant, but again, वो minus करके उसका आंसर होता है. All right, what's happening here? A chemist wishes to separate and identify a mixture of substances using chromatography. Solvent is water, so not that volatile. Solvent front is allowed to reach the top of the paper before the chemist removes the paper from the solvent. अच्छा उसने पूरा ही उसको जाने दिया है. ये कैसा scientist है? Because the problem would be that once it has reached the top, then there's no way for us to know कि उसने कितना जाना था और हमारी RF values क्या हैं. Like we can't calculate them. What will we put in the denominator of the RF value? पूरे पेज की लेंथ तो नहीं कर सकते. So for that reason, this would be wrong. Anyways, let's see the options. Which problem does this cause? This causes the spot nearest the bottom of the paper to catch up with the spot above it. That won't happen because even if they are allowed to stay for longer, they're still going to stain where they would normally stain. This makes it impossible to calculate RF value. Yeah, because we do not know what to put in the denominator. This makes it impossible to use locating it, and no, it doesn't. With this results in safety hazard. No, it doesn't. Solvent fumes, solvent है ही पानी, तो उसके क्या fumes toxic हो सकते हैं? Which particle contains the same number of both neutrons and electrons? So for that, let's just figure out the neutrons and electrons. Neutrons are this minus this, and electrons are this minus this. Okay, so 40 minus 20 is 20, and 20 minus 2 is 18, not the answer. 24 minus 12 is 12, and 12 minus 2 is 10, so not the answer. 19 minus 9 is 9, and 9 minus minus 1 is 10. So 19 minus 9 is 10, and electrons be 10 ho gaye. So this is the answer. 32 minus 16 is 16, and 16 minus minus 2 is 18. So ye bhi nahi ho sakta. All right, which statement? By the way, did you notice that the electrons that we have in these ions are the electrons from noble gases, 18 and 10? Okay, which statement is correct for all metals? Metals are soft, and so the first one is wrong. Second one is wrong because they do have positive ions, but they don't have negative ions. They have negative electrons. So that's what they have. So this is wrong. They conduct electricity by movement of electrons. Sub metals ye karte hain. Some of them are more reactive, so we don't make them into wires, but still they can do it. They conduct electricity by movement of ions. Actually, this is contradictory. And secondly, they do that if they're molten. In solids, they can't. The ions are fixed in place. X represents the element of atomic number 8, and Y represents the element of atomic number 19. So 8 is, what is 8? Oxygen. And 19 is, can anybody guess? Just check the periodic table. I think it is potassium. I'm not sure. I'll check a look. So oxygen or potassium? Kya formula banega? Y2X. That's what we'll get. K2O. So Y2X is the answer. And type of bonding, because one of them is a metal and one of them is a non-metal, it's going to be ionic. So that is the answer. Okay. The empirical formula for liquid compound is this. To find the empirical formula, it's necessary to know what. So to find the empirical formula, what do? We take the percentage mass, we divide it by its AR for every element, and using that, we can find the empirical formula. That's what we do. So 9B is the answer that we should have. Obviously, there's another way to find the empirical formula. What you do instead is that you simply take the formula and you find the ratios. So again, that is simply finding ratios. So वो भी यहाँ पे हम कर सकते हैं, लेकिन यहाँ पे हमें वो उसने बताया नहीं हुआ है, not in the option. So for example, if I told you that glucose is C6H12O6, you can simply find the ratio that it is CH2O is the empirical formula. Or if I told you the percentage mass, then you will find it. So two ways to find empirical formula. One of them is percentage composition. So ये B में हमें मिल गया. All right, 25 grams of hydrated copper 2 sulfate crystals are heated to produce anhydrous copper 2 sulfate and water vapor. Okay, so two main terms here that you need to know: hydrated and anhydrous. Hydrated means that it has water of crystallization. That dot with 5H2O, if you see, that tells me that there is water of crystallization here. And so this thing will appear blue because copper sulfate is going to be blue because of the copper ion and how it interacts with light in presence of water. On the other side, you have copper sulfate, copper 2 sulfate solid, which is anhydrous. Anhydrous simply means that it is without water. That's what it means. So you can see that the water has separated, and obviously it is because it is being strongly heated. That is how we separate water. And you can see that water is going away as gas, which indicates that it was heated. All right, what is the mass of anhydrous copper 2 sulfate formed? We just have to figure out how much of this is water and how much of this is copper 2 sulfate. Now, if this is 160, that is 5 times 90. So that tells me that if you have what, sorry, not 5 times 90, 5 times 18, what's with me? So 5 times 18 is 90, yeah. So ये 250 बन जाता है इसका MR. And for this one, it is 160. So I can say that 250 gives me 160 of copper 2 sulfate. 250 grams of this gives me 160 grams of that. So if I have 25, I'll simply get 16. It's the same ratio, right? So I'm going to get that. It's simply ratio. If you don't like that, you can use the mole method that you first convert it to moles and then you convert it to moles for the other thing. And then you find the mass. लेकिन क्या जरूरत है? Mole ratios भी given है, सारा कुछ हमारे सामने. हमें कुछ इतनी ज़्यादा complication में जाने की ज़रूरत नहीं. All right, which sample contains the most atoms? Okay, for this question, the best way to do this is to add the numbers in the formula. So ये देखो, H2O. The numbers in the formula, 2 and 1, 3. That tells me that you need 3 moles of atoms to find 1 mole of water. Or in other words, you need 3 atoms of water, 3 atoms of these things to make 1 molecule of water. Similarly, CO2 में भी वो 3 है, methane में वो 5 है, और HCl में वो 2 है. So that's what we are doing. We are adding these small numbers, okay? And now, because this is for 1 mole, we need it for 0.5 moles. So 3 times 0.5, 1.5. 3 times 1, 3. 5 times 1, 5. 2 times 2, 4. ये क्या बता रहे हैं? These are basically telling me how many moles of atoms do I need for that many moles of those substances. तो क्या किया मैंने? सबसे पहले I added all the small numbers so that I could get the number of moles of atoms I need for 1 mole of that thing. And now, after that, I multiplied by however much quantity I have to find out what is the number of atoms. So C, methane, has the highest number of atoms required. Okay. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? यहाँ पे वो टेस्ट क्या कर रहा है? 2 बातें टेस्ट कर रहा है. एक वो चेक करना चाह रहा है कि आपको ये पता है कि क्लोरीन गैस डायटोमिक होती है. ठीक है? That's the first thing. And secondly, it's trying to use the idea that if you have 2 of this, how much will be the total mass? So it's going to be 4 times 35.5, which is going to be 71 times to 142. Okay, so that's what they are testing. 2 things. Okay. 1 mole of an organic compound is burnt in oxygen and produces exactly 3 moles of water. Exactly 3 moles water produced where? They haven't told us how much carbon there is, but this is combustion analysis. 3 moles water बना है, तो organic compound है, oxygen भी हो सकती है, hydrogen भी हो सकती है, but how much hydrogen should it have? 6. Because उसको हमने oxygen में burn किया, oxygen तो कहीं से और से आ सकती है, hydrogen कहीं और से नहीं आ सकती. The only source of hydrogen is the organic compound. So the organic compound must have 6 hydrogen atoms. Baat khatam. That's it. And that is ethanol here because there is 6 hydrogen atoms. Okay, so you just add all of it up. This has 8, that has 8, that has 10. So the only possibility here is 3. In an experiment, 1 mole of powdered copper and 1 mole of powdered zinc are placed in a flask. Just some pieces of information that should come to your mind when we talk about copper and zinc. Ayla, which question are you talking about? Question number 13. Okay. So basically, what it's saying here is that you have 1 mole of compound Q that you burn in oxygen. So there's, I don't know how much oxygen, but it burns in oxygen. It gives us 3 moles water. Obviously, it gives something else as well. But 3 moles water is what we know. So what is the compound? Out of these options, which option can produce 3 moles water? Only B. If you burn A, you have 10 hydrogen atoms, you will get 5 water. If you burn C, you have 8 hydrogen atoms, you'll get 4 water. And this has 8 hydrogen atoms, you'll get 4 waters again. The only one that produces 3 water is this one. Okay. All right. So zinc and copper. First of all, you need to know that zinc is going to be gray and copper is going to be pink. Okay. Similarly, we know that zinc is more reactive, copper is less reactive. And what are we putting them in? So dilute acid is added to flask. Copper cannot react with dilute acid because copper is below hydrogen in the reactivity series, but zinc can. Zinc can react with acid and zinc can make zinc chloride, or if it is HCl, or zinc sulfate, if it is H2SO4, or whatever the salt is. But another important thing is that zinc is not transition metal. Even if it appears there, it's not transition metal. So देखें, यहाँ पे this MCQ is testing, do you know how metals react with acid? Second concept is testing, do you know the reactivity series? Zinc is more reactive than hydrogen and copper is less reactive than hydrogen. Third, do you know that zinc is not a transition metal? These are the 3 things that this MCQ is testing. So what's going to happen? We're going to get solution of zinc salt. And if it is left for a really, really long time, what's going to happen is that zinc is going to replace all the hydrogen ions, and we're going to get neutral salt dissolved in water. So we won't have any color for it as well because it's not transition. And copper will not change at all. Okay? So we have copper, it will remain as it is, 1 mole ही रहेगा, उसको कुछ भी नहीं होगा. Or zinc is going to replace the acid that you have, and it's going to form neutral salt, or colorless होगा वो. So it's going to be A. There's one thing that's produced that they haven't shown. It's going to be hydrogen gas, which goes away. Hold on. Okay. A simple cell can be made using 2 different metals as the electrodes and an aqueous solution as the electrolyte. ठीक है. Nothing new here. Which statements about simple cells are correct? Okay. Cell बनता कैसे? Simple cell में होता क्या? You have 2 metals of different reactivity. उनके reactivity different होनी चाहिए, because that is what causes the voltage difference. And the greater the difference in reactivity, the greater the voltage produced. तो 2 metals हैं, उनकी ऐसे हमने उनको dip कर दिया. कोई भी connected चीज होनी चाहिए जो water conduct करे. It can be an acid, it can be any aqueous solution, anything that allows them to conduct electricity and completes the circuit. ये जो मैंने बनाया है, ये electrolysis है, और ये जो मैं बना रहा हूँ, ये cell है. Common things, both of them have two electrodes, metal pieces that are dipped. Both of them have electrolytes. Difference, one of them has cell and one of them has voltage. One of them is going to produce electricity, which is on the right one. And that is because there's going to be a voltage difference due to difference in reactivity of metals. On the left side, we have cell, a DC circuit that's going to provide electricity to do electrolysis. Okay, so two differences, similar circuits. All right, a greater voltage is produced using magnesium and silver than using magnesium and copper. Yes, that is true because magnesium and silver are further apart in the reactivity series than magnesium and copper. Thoda sa fark hai, lekin still fark to hai. The electrolyte is an aqueous solution containing both positive and negative ions. Of course, it's an aqueous solution. Usne bola hua hai ki wo aqueous solution hai. So it will contain both positive and negative ions. The more reactive metal will release electrons. अच्छा, अब ये बात क्या हुई कि more reactive metal will release electrons. इस बात का मतलब क्या है? इस बात का मतलब ये है कि जो हमारे पास ज्यादा reactive metal है, it's going to lose the electrons and the less reactive one is going to accept them. It's a redox reaction, right? The more reactive one is going to lose it, the less reactive one is going to gain it. I don't see a difference with that. The less reactive one is definitely going to be the one where the electrons travel. So 1, 2, and 3 are all correct. So we'll say that 1, 2, and 3. All right. Magnesium can be produced by electrolysis of aqueous magnesium chloride. Okay. What are the equations for the reaction that occurs at positive electrode and at the negative electrode? हमारे पास molten magnesium chloride है. That means magnesium ion से start करना है, chloride ion से start करना है, chlorine बनाना है, magnesium बनाना है. So magnesium की reduction होगी because it's a positive ion that we are converting to solid metal. And chloride is going to be an ion that we are going to convert to chlorine. So it's going to be oxidized. So C and D show it well for chloride, in fact, A as well. And on the other side, we have magnesium, which will gain 2 electrons. So C and D are right. So which one of them is the right one? Let's see. So the D one is not balanced because it's saying 2 magnesium बन जाएंगे. एक side पे 1 magnesium है, दूसरी side पे 2 magnesium है. जादू से तो नहीं बन सकता. The law of conservation of mass tells me that whatever atoms you have, whatever particles you have on the left side is equal to the number of particles you have on the right side. So C is the right option. D में magnesium की equation does not follow the law of conservation of mass. All right. 3 different solutions were electrolyzed using inert electrodes. Okay. Which solution produces hydrogen at the negative electrode? So remember one thing, if you are dissolving salt, if you have dilute acid, it is water that breaks down. Okay? And if you have concentrated acid, it is the acid that breaks down. Okay? ये बातें ज़हन में रखनी है आपने. All right, which produces hydrogen at the negative electrode, the cathode basically. So in first one, hydrogen is going to be broken down because you have salt that is more reactive. The sodium is more reactive than hydrogen. So it's going to go. Concentrated HCl. This is again, acid is going to break down, but acid में H positive होता है, water में भी H positive होता है. So hydrogen is the one that's going to come. Obviously, it's going to come from the acid. And number 3, dilute sulfuric acid. So it's dilute acid breaks water. The electrolysis is always for water and dilute acids. So again, water. So hydrogen. So 1, 2, and 3 all produce hydrogen gas. All right, number 18. Compound Y reacts with oxygen. Okay. This reaction has a positive enthalpy change of reaction. ठीक है. This means that to let it like, इसको अगर आपने oxygen से react करना है, you have to supply energy. You can't use it to get energy out. So it can't be used as fuel, of course. It can't be a hydrocarbon because hydrocarbons are fuels. What is a positive enthalpy change? Positive enthalpy change means that the energy of bonds that you've broken was higher, and the energy of bonds that are made is lower. So the amount of energy that you have to give in was more, and the amount of energy that was given out was less. So based on that, we can see that this is going to be, yeah, C. C defines it well. So C is the answer. All right, formation of liquid water from hydrogen and oxygen may occur in 3 stages, which they have told us. Which stages are endothermic? Bond breaking is endothermic, bond making is exothermic. Let's see first में क्या हो रहा है. First में bonds break हो रही हैं. You are getting atoms on the right side. You have atoms, and that means no bonds made. So this is bond breaking. It can be endothermic. Second stage, you are getting atoms converted to molecules, so bonds are being made. This is exothermic. And third one, you are converting it from gas to liquid. So basically what you're doing is you're getting energy out of water molecules, because at gas, they have higher energy. As liquids, they have low energy. So you're basically extracting the energy that they have. So again, that is basically you're making them lose energy जो उनके पास है. So only one is the one that is bond breaking entirely. 2 and 3 both are releasing energy in one way or another. So B is endothermic. 2 and 3 are exothermic. Sulfur trioxide is produced by the following reaction. We know this reaction. We have seen it in vanadium 5 oxide. We know that that's the catalyst in this thing. We also know that it happens at 1 to 2 atmospheric pressure, and it also happens at 450 degrees Celsius temperature. Okay, so those are the conditions under which we do it in industry. And the reason we do this is because we want to create sulfuric acid from this. Okay, which changes in condition could produce a greater amount of SO3 at equilibrium? Right side को shift करना है हमें equilibrium को. So let's see, it's an exothermic reaction. तो अगर मैं temperature decrease कर दूंगा, so उसको increase करने के लिए right को आएगा. That's one. I have 3 moles of gas on the left side and 2 moles of gas on the right side. तो इसका मतलब है अगर मैं pressure बढ़ा दूंगा, the left side will react more and it will push it to the right. So that's one, you increase the pressure. The other is you decrease the temperature. Another option is that I increase SO2 that I have, or oxygen that I have. I blow more oxygen in. So all of that is going to give us more sulfur trioxide. So let's see which option matches it. It says add a catalyst. Adding a catalyst will speed up the reaction, but for both sides. So it's not going to help us in shifting the equilibrium to one side. Increasing the pressure, definitely. The left side has 3 moles of gas, right side has 2, so it can easily drive the equilibrium to the right side. C will push it back, and D will also push it back. So B is the answer. We're done with half of the paper. Good. Magnesium reacts with sulfuric acid, dilute sulfuric acid, okay. 2 experiments were carried out. In one, 24 grams, दूसरे में 24 grams. ठीक है जी. In one, you have 100 cm cube of 1 mole per dm cube sulfuric acid. In the second, you have 50 cm cube of 2 mole per dm cube sulfuric acid. एक में amount कम है, volume कम है, लेकिन moles double है. Concentration ज़्यादा है. What's the total number of moles? Let's see. In first one, you are going to get 100 times 1. So N equal to CV. 100 cm cube को आप dm cube में convert करना चाहें कर दें. But let's keep it simple. 100 times 1 and the other one is 2 times 50. The total amount is still the same, roughly the same. In fact, exactly the same. So the amount of gas produced won't change. So D नहीं हो सकता, C नहीं हो सकता, because the number of particles is the same. But हो क्या रहा है? In each experiment, the volume of hydrogen was measured. Which one is going to be reacting faster? The one with higher concentration? You have more particles in lower space. So that's the one which is going to be faster. So experiment 2, the dotted line is going to be faster, but producing the same amount of gas, same volume of gas as experiment 1, which is in the solid line. So A is the answer, where dotted line is faster. Which statement is correct for both aluminium and iron? Okay. Both form positive 2 ions. Yeah, they do. Aluminium भी positive 2 बनाता है ना, और iron भी positive 2 बनाता है. ऐसे ही है. Guys, ऐसा नहीं है. Aluminium is positive 3. Iron is +2 and +3. दोनों बनाता है, but aluminium is only +3. So this can't be right. Both have amphoteric oxides. Again, we know that aluminium oxide is definitely amphoteric, but we don't know that for iron oxide. In fact, that is basic. The manufacture of both metals involves reduction of metal ions. दुनिया का हर metal reduction के through बनता है सिवाय precious metals के. If you're getting a pure metal out in the wild, so वो तो ठीक है, वो आपको reduce नहीं करना. But you will be reducing any metal ion that you get in nature. So yeah, this is true. Gold was precious, silver was precious, platinum was precious because it was easy to find them in pure form. Aluminium was ridiculously expensive at one time because it took a lot of rare conditions for you to get pure aluminium. लोगों को redox reactions नहीं पता था. So I remember there was this famous story that Napoleon Bonaparte, the king of France, if you were a guest at his house, you would get served in cutlery made of gold because you are a guest at like King of France ने बुलाया आपको. But if you were a special guest, then you would be called in and you will be served in cutlery or silverware of aluminium. अगर आप special guest हो, because it's the highest honor that you can have because it's so ridiculously expensive. आजकल हम क्या करते हैं? We wrap our Johnny and Jugnu burgers in that aluminium. All right. Household cleaning compound is used to remove calcium carbonate from bathroom surfaces. ठीक है जी, कर लिया. Cleaning compound क्या होगा? सीधा सीधा कोई acid होगा, calcium carbonate base है, उससे react करेगा. Compound reacts with calcium carbonate to form a soluble salt, carbon dioxide, and water. No wonder. What is the pH of this cleaning compound? Acid होगा तो करेगा. So there's only one that has it as acid. The other options are neutral or basic. So obviously it's going to be A. All right, dilute HCl is added separately to samples of copper, copper-2 oxide, and copper-2 carbonate. We are adding acid, okay? We know that dilute acid do not react with pure copper, but they do react with its salts. So copper-2 oxide से reaction हो जाएगा. Copper-2 carbonate will react with it, but pure copper will not react with it. It's dilute acid. Hydrogen ion is more reactive than copper. So we are going to get D as the answer. All right. Which ions are present when hydrochloric acid has exactly neutralized aqueous sodium hydroxide? बहुत ज़्यादा क्वेश्चन है एसिड बेसिस के इस चैप्टर में, इस पेपर में. Which ions are present when HCl has exactly neutralized aqueous sodium hydroxide? Neutralize हो गया तो सोडियम आयन है, क्लोराइड आयन है और वाटर है. ठीक है, exactly neutralize हो गया ना, तो उसका मतलब है कि वाटर मॉलिक्यूल्स बन गए हैं उसके पास कोई. अब वाटर कैसे प्रोड्यूस होता है? वाटर में H पॉजिटिव होता है, वाटर में हाइड्रोक्साइड नेगेटिव होता है. So that's it. That's what you have. 25A. Which experiment will result in the formation of a white precipitate? Let's see. White precipitate है तो वो नहीं हो सकता ट्रांजिशन मेटल, और precipitate है तो insoluble salt होना चाहिए, जिसका मतलब snap salt नहीं हो सकता. जिसका मतलब है कि अगर सल्फेट होगा तो प्लीज कॉल बैक. अगर कार्बोनेट होगा, फॉस्फेट होगा, हाइड्रोक्साइड होगा, ऑक्साइड होगा तो इनसॉल्युबल होगा. और अगर हमारे पास हैलाइड होगा तो सिल्वर, लेड और मर्क्यूरी होगा. ठीक है. ऑलराइट, सो बेरियम नाइट्रेट एडेड टू सोडियम क्लोराइड. बेरियम क्लोराइड बनेगा सॉल्युबल, सोडियम नाइट्रेट बनेगा सॉल्युबल. सोडियम कार्बोनेट एडेड टू कैल्शियम क्लोराइड. स्नैप सॉल्ट है एक तो, और दूसरा कैल्शियम कार्बोनेट है. कैल्शियम कार्बोनेट इज इनसॉल्युबल, व्हाइट प्रेसिपिटेट बनेगा उसके अंदर. ओके, कार्बन डाइऑक्साइड पास थ्रू पोटेशियम क्लोराइड. पोटेशियम क्लोराइड के साथ ये रिएक्शन करता है या नहीं करता है, इट इज वे बियॉन्ड आवर ओ लेवल की रिक्वायरमेंट. हमें इसको पता ही नहीं करना कि क्या करता है, तो छोड़ दो. एंड डाइल्यूट HCl to aqueous ammonia, it's going to form HCl, but HCl is soluble. तो व्हाइट क्या कुछ भी कलर नहीं आएगा. HCl भी कलरलेस, अमोनिया भी कलरलेस. Can anybody tell me, if you were to do this reaction, what procedure will you follow? HCl or ammonia, if you were going to react them, what procedure will you follow? ATP वालों जरा बताओ. titration, because that's how you know exactly how much of the reactants you need. If two reactants are aqueous, both of them, you will use titration. Okay. Which statement about both the group 1 and group 7 elements is correct? ठीक है जी, देखते हैं. They conduct electricity when molten. Group 7 कैसे करेगा? Non-metal नहीं कर सकता. They form covalent compounds. Impossible. They are ionic. One is metal. They exist as diatomic molecules. Group 7 does. Group 1 doesn't. When group 1 elements combine with group 7, ionic compounds form. Perfect. बिल्कुल ऐसी. Example: sodium chloride. Elements helium, argon, neon are noble gases. Okay. Which statement is correct? All these elements have 8 electrons in their outer shell. All these have 8 electrons in the outer shell is true for argon, neon, but not helium. It has 2. Argon is used to react with impurities in the manufacture of steel. Argon is used in manufacture of steel. लेकिन reaction वाली उम्मीद नहीं रखें आप इससे, because it is unreactive. It is a noble gas. For impurities, we have oxygen. Helium is used in balloons as it is more dense than air. It is used in balloons, but because it is lighter than air. ये कौन सा balloon है जो sink कर रहा है? ऐसा तो नहीं हो सकता. Neon is used in light bulbs to give an inert atmosphere. That is true. We use it. Neon and argon, we use both of them because we want inert atmosphere. Which shows the correct catalyst for each industrial process? देखें आपका assessment objective 1, knowledge with understanding. ये knowledge वाला है, ये recall का question है. याद करना है, इसमें कुछ concept आपके लिए नहीं है. वैसे बहुत सारी इसके पीछे science है कि निकल क्यों use करते हैं hydrogenation में, लेकिन यहाँ पे आपको नहीं चाहिए, आपको याद करना है. So for sulfuric acid, vanadium 5 oxide. For ammonia, iron. For margarine, nickel. Remember this. Make a list. Note it down. Burn it to your memory. In the solid state, germanium has the same structure as diamond. ठीक है जी. तो अब हम germanium को diamond जैसे सोचेंगे. What is likely melting point? बहुत ज़्यादा. जितना ज़्यादा हो सकता है, जितनी option है, वो आपके पास answer होगा. So above 800 is good. What is so special about 800 anyway? So 800 is good. Above 800, 8. Aluminium is a metal that is often used to make caps for bottles. ठीक है. When thrown away and buried in the soil, the caps do not corrode. Basically, सवाल क्या कर रहा है वो? कि aluminium unreactive क्यों है भाई? The aluminium is unreactive because it has a layer of oxide on it. वो caps में हो या वो किसी और चीज में हो, it has a layer of oxide on it. So D is the answer. Which statement about group 1 metal is correct? Group 1 का हमें क्या पता है? Soft होते हैं, low density, low melting point. Low density की वजह से they float on water, very reactive, and they react with water, producing hydrogen gas. ये सारी बातें हमें पता हैं group 1 के बारे में. And obviously they have positive 1 charges. Okay, so they're hard गलत है, they form colored गलत है because they are not transition. They have low densities, that's why they float. So C भी गलत है. D is right, they only form ions with positive 1. Yes. CFC compounds were used as aerosol propellants. CFC में आपको पता होना चाहिए कि ये क्या है? Chlorofluorocarbons. They have carbon bonded to chlorine, which is the bond that breaks at higher atmosphere. वहां पर ultraviolet light होती है, carbon chlorine bond टूट जाती है, and that chlorine then simply depletes the ozone, damages it. So the answer here is which element is responsible for depletion of ozone? Again याद रखना है, chlorine. अब उसकी reason ये है कि carbon chlorine bond is weaker, carbon fluorine bond is stronger, carbon hydrogen bond is stronger, carbon carbon bond is stronger. In sub bonds में carbon chlorine is the weakest one, which is why it breaks. लेकिन आपके पास कोई डेटा तो नहीं है ना कि आपको याद हो कि ये वैल्यूज कहाँ से आ रही हैं. IGCSE में वैल्यूज दी होती हैं, बट अगेन वो यहाँ पे नहीं है. MCQ में तो IGCSE में भी नहीं दी होती हैं. So you just have to know that it is chlorine. Dry air is a mixture of gases which is 99% is nitrogen and oxygen. ठीक है, बिल्कुल सही है. What's the main constituent of the remaining 1%? 1% में होता क्या है? आपके पास कार्बन डाइऑक्साइड होती है, आपके पास आर्गन होती है, आपके पास वाटर वेपर होता है, लेकिन ये ड्राई एयर है. ड्राई एयर में तो वाटर वेपर नहीं होगा ना. So that means what you're left with is argon because that is the most abundant gas after nitrogen and oxygen. Why is chlorine added to water supply? क्यों यूज करते हैं? Chlorine when dissolved in water makes acid. That acid breaks bacteria. Oh, sorry, damages bacteria, kills them. So B is the one. अच्छा, बाकी stages के लिए देख लेते हैं. Removes taste and odor, that is carbon. Removes precipitates solid that may be present. इसके लिए हमें कोई भी एजेंट चाहिए होगा जो ये काम करे. There was a lake जहाँ पे लोगों ने करने की कोशिश की थी and it was quite successful. So, but that's not chlorine. Chlorine is used to desalinate water. That you do through either a reverse osmosis machine or you do it through evaporation and crystallization वाला सारा process. Distillation के through basically. All right. When alcohol of molecular formula C4H10O is oxidized, ठीक है. What's the molecular formula of the acid formed? Alcohol को oxidize करते हैं, carboxylic acid बनता है. Yes. उस कार्बोक्सिलिक एसिड में कैसे बनता है? यू आर बेसिकली एडिंग हाइड्रोजन एंड ऑक्सीजन. उन्हीं को आप ऐड कर रहे होते हैं. हाइड्रोजन रिमूव कर रहे होते हैं, ऑक्सीजन ऐड कर रहे होते हैं. सही है. तो 4 कार्बन हैं, 4 ही रहेंगे, फर्क नहीं पड़ेगा उसको. क्या फर्क पड़ेगा? यू रिमूव 2 हाइड्रोजन, यू ऐड 1 ऑक्सीजन. सो इट हैज 1 ऑक्सीजन, दे विल बिकम 2, एंड इट हैज 10 हाइड्रोजन, इट विल बिकम 8. That is how you form, that is how you oxidizes, and that is how you form carboxylic acid. The diagram shows the structure of 5 hydrocarbons. ठीक है जी. इनके नाम देख लेते हैं. First one is pentane. Second one is 2,2-dimethyl propane. क्यों? Second carbon. There are 3 in the long chain. ठीक है, कहीं से भी आप देख लें, long chain में 3 हैं. And on the second one, middle one, you have a branch methyl, and this is also methyl. So 2,2-dimethyl. Third one is simply the same long chain as the first one. कोई branch नहीं है उसमें. This one has a branch. So long chain is butane, and that is not. So 1 and 3 are isomers. अच्छा. Sorry, 1 and 3 are not isomers. They are the same molecule. बस उसको bend किया हुआ है, उससे क्या फर्क पड़ता है? अच्छा. 5 में क्या हो रहा है कि you have 2-methyl propane. So which 3 hydrocarbons are isomers? 5 कार्बन किस में है? 4 में 5 हैं, 1 में 5 हैं, 2 में 5 हैं, और 3 को तो काउंट करेंगे नहीं because 1 and 3 are the same. So 1, 2 and 4. There you go. Which alcohol and acid will react together to make this ester? अब ester के लिए आपने ये ध्यान में रखना है कि the side with the O is coming from the alcohol and the side with the CO is coming from the acid. So acid कौन सा होगा? CH3COOH. और alcohol कौन सा होगा? C2H5OH. Ethanol, ethanoic acid. Those are the ones responsible for this ester, and it is ethyl ethanoate. So आपके पास C आंसर होता है इसका. All right. Which compound has a pH of less than 7 in aqueous solution? Acid कौन सा है? असल में वो ये पूछना चाह रहा है आपसे. तो acid identify कर लें, उसमें COOH होगा. So that is C. बाकी सब क्या है? B is something that you don't study in O levels. It is called aldehyde. We don't study that. A is an ester, D is an ester. Last question, which statement about polymers is correct? Nylon and terylene are produced by additional polymerization. No, they are produced through condensation polymerization because they have linkage in it. Anything that has linkage is a condensation polymer. Nylon and terylene both contain the amide linkage. Actually, it's nylon and protein. And terylene and fats have ester linkage. याद करना है, याद करना है. Simple sugars can be produced by hydrolyzing proteins. ऐसा हो ही ना जाए हम proteins खा के भी मोटे होना शुरू हो जाएं सब लोग. ठीक है? So this is wrong. Starch contains the elements carbon, hydrogen, oxygen. Yes, protein is the one that contains nitrogen in addition to these 3. So starch is a carbohydrate. So D is the answer. And there you go. That is the paper. This was 2017. Paper 1-2 winter 2017. So I hope समझ आ गया. अगर कोई question है, you can just ask. Michelle's question is that hydrolyzing means adding water. Yes, it does. Yes, definitely. Okay. And I'll share the link. It's actually in If you go to WhatsApp group and its description, you will find the link there.